Hello, in this video I would like to explain different types of milling cutters and the type of material used for milling cutters and its elements. So here milling cutters. Milling cutter is a cutting tool used for milling operations. So this is the cutting tool used in milling machine. Varieties of milling cutters are available for getting different shapes or for getting different profiles. Milling cutter materials. So these are some characteristics of the cutting tool materials. Just like other cutting tools also, here, the cutting tool should be very harder than the metal being machined, and it should be strong enough to withstand cutting pressures or forces, and it should be tough enough to resist shock resulting from cutting contacts, and also it has to resist the heat and abrasion of cutting, and it must be available in different shapes or profile to get the different required shapes on workpiece. So one of the cutting tool material is the high speed steel. The main ingredients of high speed steel are carbon, tungsten, chromium and vanadium. The carbon will enhance the hardness. The tungsten and molybdenum, it will enable the steel to retain the hardness at high temperature. And chromium increases its toughness to resist the wear. The vanadium increases the tensile strength of the cutting tool. Another cutting tool material is the cemented carbide, and it is comparatively harder than the high speed steel and can be used for high rates of production or where we want to increase the depth of cut as well as the speed of cutting. So for fast operations you can use cemented carbide tool. It is 3 to 10 times faster than HSS, and you must select the proper type of carbide. That is very important. So based on the type of the work material we have to select the like tungsten carbide, tantalum carbide, tungsten titanium carbide, etc. These are the different combinations. So based on the type of workpiece we have to select the suitable cemented carbide tool. Other materials are also the ceramic inserter tool is also available, then diamond insert is also available. So these are the varieties of tools materials used for milling cutters. Now we'll see different types of cutters. So this classification is based on the profile or the shape of the cutter and the action of cutting. The plain milling cutter. So this is the simplest form of milling cutter, and here the teeth are only on its periphery. This is the periphery of the cutter. This is the periphery of the cutter. And the plain milling cutter, the cutting edges or the teeth are on its periphery only. It is not there in the face. This is the face. And here some cutters, the cutting edges are parallel to the axis of the cutter. So this is the axis of the cutter. In some plain milling cutter the cutting edges are parallel, and in some other cutters the cutting edges are inclined, just like a helical shape. Both are available, and this plain milling cutter is also known as slab cutters, and this is widely used for generating flat surfaces on horizontal milling machine, and this is used in horizontal milling machine where the arbor is there. Arbor holds the cutter, and in the horizontal the axis is in the horizontal direction. Different types of plain milling cutters are available, and this is the simplest one where the the cutting edges are parallel to the axis of the cutter, and here you can see the cutting edges are inclined, so helix angle is there, and here the helix angle is 25 degree. This is for light duty plain milling cutter, And compared to the straight cutting edge, this inclined cutting edges are comparatively better performance. Because of this inclination, shearing takes place faster, and the metal removal metal removal process is also very simple, and the metal removal rate is also high. So widely these type of cutters are widely used rather than the straight cutting edges. Then heavy duty, the inclination again increases. The helix angle is up to 45 degree. So this is used for heavy duty because the metal removal rate can be increased very high. The metal removal rate is also very high. Then the helix, high helix plane milling cutters, this is up to 60 degree. The helix angle is up to 60 degree, just like a drill bit. You can see this helix, and suitable to milling wide and intermittent surface on contour and profile cut. Sometimes shank mounted with a pilot on end. That is also sometimes there will be a pilot tip on the end of the cutter for milling elongated slots. Standard shank type helical milling cutter. This is a cutter which is having a shank just like drill bit. So a type of shank is also there, and it is called arbor type cutters used for milling forms from solid metal, removing inner sections from solid. So this is comparatively, the diameter of the cutter is comparatively small, so you can insert into a hole or a cavity, and can be done, the inner surface can be machined by using this standard shank type helical milling cutter. Then comes the side milling cutter. Side milling cutter. So here you can see the cutting edges are there on the sides of the milling cutter, on the sides, sometimes both sides or from sometimes one single side. So the side milling cutter, the cutting edges are on its periphery as well as on the sides. Comparatively narrow cylindrical milling cutters with the teeth on each side and on periphery. That is the one of the important difference between the plain milling cutter and the side milling cutter. Plain milling cutter, the cutting edges are on its periphery only, but in side milling cutter, the cutting edges are on periphery as well as the sides. Used for cutting slots and for face and straddle milling operations. Straddle milling operation means you can have multiple cuts can be done at a time. That means by using multiple cutters. So strad milling cutter uses the side milling cutters. Strad milling operations, straddle milling operations uses side milling cutters. And also this is also used in horizontal milling machine where the axis of the spindle is horizontal. Free cutting actions at high speeds and feeds, and this is suitable for high speed and feed, and for milling deep narrow slots. So this the normally the width of the cutter is comparatively very small, so we can have narrow slots by using this cutter. Half side milling cutter, this is similar to the side milling cutter, only the difference is one side is there is no cutting. That means one side there is no cutting edge, it is completely flat. So only we can cut by using the periphery and the other side of the cutter, uh, and its rake angle is considerably high and able to take heavy cuts. So as the rake angle is high means metal removal rate is also high, so you can take more cut, depth of cut can be high. And the face milling cutter, this is widely used in vertical milling machine. That is very important. This is used in vertical milling machine for cutting, for machining flat surfaces and for machining pockets. So here you can see the cutting edges are on face as well as on periphery. Both are there on face and the periphery. And this is in the vertical milling machine where the spindle is vertical, and this actually this surface is in the bottom of the spindle. Bottom of the spindle, the surface will come, and this is the surface which touches the workpiece. So while rotating this one, the peak from this cutting edge and the periphery, both the material will be removed from the work surfaces. And this is widely used for generating flat surface on a slab or any workpiece. Most cutting action occurs at the beveled corners and the periphery of the cutter. So the cutting action mostly done because of this periphery as well as this corner, this edge. Makes roughing and finishing it in one pass. So by using the as we can give more depth of cut, so sometimes we can complete the machining in one pass. N milling cutter. In N milling cutters are also face milling cutters. The difference is it is having cutting edges on both the periphery as well as the face, and solid multiple tooth cutters with teeth on face and periphery held on step arbor, may be threaded or use key in shank to drive cutter. So this is the normally used. This shank type holder is used for N milling cutter. This is comparatively smaller. That is the difference. The diameter of the milling cutter is smaller. This is used for making pockets in a metal or for getting cavity. So for example, for machining a mold cavity, you can use this type of N milling cutters. So the cutting action will be from the periphery as well as the from the face. So this is comparatively, this is also used in the vertical milling machine where the spindle is vertical. Angular cutters. Here the teeth is neither parallel or perpendicular to the cutting axis, but it is inclined, sometimes in both sides or sometimes in one side. Used for milling angular surfaces. Also used for grooves, serrations, chamfers, and reamer teeth. There are two types, divided into two groups: single angle milling cutters and double angle milling cutters. Both are available. So these are the cutters, angular cutters. This is single angle and this is the double angle. On both sides the cutting edges are inclined. Teeth on angular surface, maybe the angle is from 45 degree to 60 degree. In double angle it is two intersecting angular surfaces, both directions, the cutting teeth on both, and equal angles on both sides of the line at right angle to axis. So this is used for machining slots, keyways, etc. And also this is used in horizontal milling machine, not vertical. This is used in horizontal milling machine where the spindle is horizontal. Formed cutters or forming cutters. So this is to get an exact shape of the part to be produced. So the shape can be any shape. So whatever the shape required, you have to manufacture, you have to make the cutting tool or the cutter in the respective shape to get the required shape. Useful for production of small parts. And sometimes you will be getting the required shape in single pass. That means you can adjust the depth of cut and give a single pass, you will be getting the required shape. For example, convex, concave, angular cuts, any profile, any contour can be cut by using forming cutters. Uh, Important to maintain original rig, difficult to sharpen. That is one of the drawback of the this formed cutters, because we are manufacturing the cutter based on the required shape. So when you want to again sharpen the cutting edges, then that will change the profile or the shape of the cutter, so it is not possible. So these are the some of the formed cutters. You can see this is concave cutter, so you can see the profile concave, and this is convex. So when we machine the workpiece by using this concave cutter, you will be getting a convex surface on the machined surface or the workpiece. Here this is convex, so you will be getting a concave surface on the workpiece. And the gear tooth, this is widely used for cutting gears. So based on the profile, pitch, etc. of the gear, you can select the cutter. So these are all coming under the foam cutters. Then this is also widely used for parting of operation. That means you want to cut the material into two pieces, just like a saw. You can use a milling cutter. This is very thin. The width is very small. Basically, thin plain milling cutter. So basically, this is also a plain milling cutter. Plain milling cutter because the cutting edges are on its periphery only, and width is 1 by 32 or 3 by 16 inches, operated at approximately one fourth or one eighth of a feet per tooth used for other cutters. So the feet per tooth is also small. Not advisable to keyshaw to milling arbor. So this cannot be used in milling arbor because this is very thin. So the width is very small, so we cannot use that arbor. Backlash eliminator should be engaged. That is also important. There is a chance of backlash. So these are the metal slitting saw cutters. You can see here the width of the cutter is very small. This is just like a saw, where we can see this type of saw used for wood cutting. So the similar things, only the thing is the difference is the metal is harder than the cutter used in wood. So when we want to machine the metal, we have to use a hard material for this cutter. End milling cutter. So here also end milling cutter already explained. Here the cutting teeth are on both its ends as well as the periphery. This is used for making pockets, cavities, etc. And this is used with a tapered shank cutter holder. This is the figure. You can see this is the shank holder, and this is the cutter. And normally this is the small diameter cutter, and these are the cutting edges on both its periphery as well as the end or face of the cutter. This is widely used in small pocket for manufacturing, for machining small pockets, grooves, etc. This is dovetail cutter. If you want to produce a dovetail groove, you can use this one because here the periphery is tapered. That's the difference. This is also an end mill with the periphery with an inclination or about 45 to 50 to 60-degree angles to provide here in the cutting edge. Woodruff key seat cutter. This is similar in design of the plain milling cutter and side milling cutters. A small up to 2 inches solid shank, straight teeth, large mounted on arbor with staggered teeth. So this is used in arbor in horizontal milling machine for milling semi-cylindrical key seats in shafts designated by number system. So this is not commonly used cutters for special purposes. Fly cutters is having single point cutting tool, just like insert, it is inserted here with the cutting and ground to desired shape, mounted in a special adapter or arbor. This is the adapter. So this one uses a special type of adapter. This is the cutting tool. So a small cutting tool, it is fixed on the end of the arbor, and this is also for special purpose used in experimental work instead of a specially shaped cut. So thank you very much. These are all about the different types of milling cutters.